It's grad season right now while I'm making this video. So usually I don't look this good on a Saturday, but hey, I got some grad parties to go to. So let's continue on with the review. The normal way of finding P of 3 is, remember, this is the input. Your job is to find the output. You just sub it in. Always a good idea to use parentheses in case you have a negative. And again, just type it in your calculator, hit enter. You don't need to do a big funnel with order of up. The other way of doing it is synthetic division. Now you have a 1, a -4. See how you have 0x cubed? So you need to have a place value holder for that. You have 9x squared, and then you have 0x's minus 8. Just kind of like the difference between 34, 3004. Those zeros hold places. So if we don't see them, we think it's 34. If we see them, we know it's in the 3000 range, okay? Synthetic division, we put the 3 here, bring down, multiply, add, multiply, add, multiply, add, multiply, add. Your remainder is the same as that, okay? So whatever your remainder is should be the same as that, okay? Imaginary number come in conjugate pairs, right? Like Noah's Ark, they come 2 by 2 by 2. So if you have 1 plus I, 1 minus I is going to be the other one, okay? All right, and then let's see, I think I have the work to this one on another one. Okay, so this is bounds. I might have this be an extra credit question, so listening to this video is a good idea. One way to find upper and lower bounds, which means you know you're going to see all the zeros on your screen, either in Desmos or on a TI, is you do synthetic division. And if the output is all positive, you know that there's no more zeros after that. So positive 10, when I do synthetic division, I get all positives. That tells me that my cutoff of 10 is going to show me all my zeros, okay? And sometimes students are like, well, I'll just do the rational zero theorem, 20, plus or minus 1, plus or minus 2. That only gives you, remember, pretty ones. It doesn't give you, so like if the square root of 87 is out there, that doesn't tell you that. So if you do synthetic division with like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so forth, and you get all positive outputs, you know that you have found the highest values possible, that there can't be any lurking, like the square root of 87 cannot be lurking here. So 10 is good enough for your X in your window. Same thing with negatives, except the output. So if you do synthetic division with like -1, -2, -3, -4, -5, 6, 7, 8, 9, 10, and so forth, if you get an output that alternates, so positive, negative, positive, negative. Now, zeros can act as positives or negatives, okay? So if you have, like, say you do synthetic division, you get -8, 0. So that could be like negative, positive, negative, and then maybe positive. And then this could actually be negative, believe it or not. So zeros are neutral. They can be either positive or negative if you need them to, okay? So this would still be alternating because it's negative, neutral, negative, positive, neutral. That would still be considered alternate. So synthetic division, it alternates. That tells you that that is a lower bound. Okay, so what that means is there can't be the square root of 141 out there. Okay, all right, because that's past, or negative square root of 141 because it's past this. I think I said square root of 87 in there. That would be less than 10. So that could be in there. This would have to be the square root of, whatever, 213 or something that's past the square root of 100. All right. So that might be an extra credit on the test. So just an FYI. All right. The next one, how can you tell without graphing? Okay. So remember, this is an intermediate value theorem. And these are both inputs, right? Because I want to know between X equal that and X equal that. So if I sub in X, okay, and again, I would just do this on a calculator. I just showed my work in case you wanted to see it. I just type it in, hit enter. Same thing here. I would just type it in and hit enter. And again, parentheses are a good idea for input because then if it's a negative, you're safe. All right. So here I get a negative output. Here I get a positive output. So remember what that tells you is if you're at what? 1, where am I at? -5 and at 2, +1, right? If you have a negative output and a positive or vice versa, right, it has to cross somewhere in there. So there has to be a 0 or an answer or a solution somewhere in between 1 and 2, okay? All right, so you can find it. All right, find all the possible zeros. Okay, I don't want you to find which ones work here. I am just saying, hey, find all the possibilities. So remember, I like to remember the last shall go first. So the factors of the last, which are 1 and 7, plus or minus, could be negative or positive, over the first. So factors of 4 are 1 and 4, and then 2 and 2. And then remember, don't make me divide. So these are 2 of them. And then if I take that, divide by that, that's a repeat. This is a half. This is a fourth. Those are new ones. And then if I do this way, 7 is a repeat. 7 divided by 2 is a new one. And 7 divided by 4 is a new one. And again, it could be, ignore that. It could be the positive and negative of either one of those. Okay. So it just, kind of depends on. All right, so those are all the possible. Okay, so the next one says graph, okay, and my numbering's a little different. This is an older answer key. So for you guys, this is what, number, maybe the graphing, yeah, I think the numbering's the same. It's just a placement on the paper. Okay, it says, without using a graph hint, find all the zeros. Okay, the last shall go first. I'm dividing by 1. So really, I only have 8 things to check. I started with 2. I just got lucky. Okay, so, I didn't have any pre-knowledge. So 1, -4 did synthetic division. I got a remainder of 0. So remember, factors are opposite of 0. So if the 0's at 2 or the answer's at 2, solution's at 2, the factor is x minus 2. Now notice you don't want to keep doing synthetic division with these guys because usually you can just factor that or do quadratic formula or something. So I factored that and I got all 3. Okay, factors. Now, this is the third power, and I have 3 answers, which is great. So I have a 0 at a -1, because that causes that, +2, +3. Notice they're all odd powers. I know it goes through. My overall power is odd, and it's positive. So this is kind of that disco end behavior. So I know it's going to go through. I also, if I sub in 0, I can see my y-intercept is 6. So I'm going to go through there, come down. And again, I have that nice disco behavior. These all go through. This is accurate. This point, I don't really know. I mean, if you really want to know, like, do you guys get, you could sub in 1 and be more accurate there, but I don't really care. I just want to get the overall shape of the graph. Okay. All right. Divide using long division. Again, you can't use a synthetic on this because of the darn squared. Remember, the steps here are match. You match, you distribute, you opposite, you bring down. You match, distribute, opposite, bring down, match. So 18x squared matches, distribute. So you get that 36x, make them opposite, bring down, and that's that whole process. All right. Why does synthetic division not work? Because again, of that darn x squared, you need just a plain old x with, just a nice little number over there to work. Okay. All right. Let's see what's next on that. Let's look at this one. Okay. So this one says, find all the zeros of that without a calculator. Okay. You could do the last over the first and try things there, but notice, I noticed I could factor by grouping. I took out GCF, x cubed. I took out GCF of 1. You got to take something out. See how you get a 2x minus 1? That's my new GCF. So those, they have that in common, and my leftovers go here. And then, okay, a cubic. All right, this factors. And in algebra, you probably memorized it. All I memorized about this is that x plus 1 for sure can come out. If it's x cubed minus 1, x minus 1 can come out. If you have x cubed minus 8, x minus 2 can come out. If it's x cubed plus 8, but it has to be a cubic with a cubic, okay? How I do this is you know me, I don't like to memorize. So what I do is I do synthetic division here. So I know that for sure x plus 1 comes out. So I'm going to do a -1 with synthetic division. This is what? A cube. So 1, no squareds, no x's, and then my 1, okay? Bring down my 1, multiply, bring down, multiply, bring down, and multiply, bring down. Okay, so see how I get x squared. Let's see, what do I have? I have x squared. What did I do? Oh, x squared minus x plus 1. So this becomes x squared. This is my x. This is my plus 1. That's this guy over here. Okay, so I'm going to take an x cubed or x plus 1 out of there. This is this guy over there. That was bothering me for a second. I didn't write them next to each other. I apologize. So these two make that. If you know just that x plus 2 comes out of here, you can do synthetic division to see what the leftovers are. All right. So now, what causes 0? -1. What causes 0? That'd be positive half, right? Because you set it equal to 0. Bring the 1 over. And you get 2x equals 1 divided by 2. Okay. This guy is either going to be imaginary or a radical of some sort. So I did opposite of b plus or minus b squared minus 4ac all over 2a, quadratic formula. I got a -3. So the square root of 3 is the square root of 3. The -1 comes out as an I. Okay. And so notice this is to the 4th power. You should have 4 answers. Now, it doesn't mean they're not all real. 2 of them are real. 2 of them are imaginary. And remember, imaginary numbers come in conjugate pairs. So that makes sense to me. All right, let's look at the next one. Let's see. Here it says find all the zeros in the multiplicity. Okay, so 1 causes 0. It's to the, let's see, where am I at? Ooh, I had to factor more. Sorry. X squared minus 1 is a perfect square minus a perfect square. That has to factor more. All right, so let me come over here. I have x minus 1 cubed. I factor that guy again into x minus 1, x plus 1. And then this guy is going to give me my imaginaries over there. So x minus 1, I can make that to the 4th power. So where did I do that? Oh, I don't know if I ever did an intermediate step. So let me do that. X minus 1 to the 4th, x plus 1. And then this guy is going to give me my imaginaries. Okay, so all the zeros. I should have what? There's 2, 3, 4, 5, 6, 7 zeros. Okay. All right. So this guy, positive 1, is to the 4th power. I don't know why I wrote that. I don't know. Sorry, not a good day. All right. So to the 4th power, and the -1. Okay. So, oh, Julie, I am having a heck of a time here. All right. I'm going to back up a second.